So in principle, an alien civilization could have been doing some form of science for unfathomably long. What could they know about the universe? And could they come here and just tell us, right? Imagine leaping forward into our scientific future 1,000 years, 1,000,000 years. Like it's mind blowing.
So thanks for joining us today. We've got a special chat that we're going to be having today. I'm pleased to be joined by one of my colleagues from the ATLAS experiment. So I have Professor Daniel Whiteson, who is a physics professor, physics and astronomy professor at the University of California, Irvine. And as I said, we work on the ATLAS experiment together. So maybe we can start off this chat by talking about your physics research and what you've been doing in ATLAS. Maybe you can tell us a bit more about that side.
Sure. Yeah. So, we're operating the largest accelerator in human history, colliding protons at the highest energy in human history, which is exciting because it means that we can create stuff that hasn't existed since the early universe. And so, my focus, my research, Atlas is a huge project. Everybody focuses on different things, is using machine learning to try to extract as much information out of those collisions to look for new weird stuff. So, for example, right now I'm working on particles that leave strange tracks in our detector. Maybe they don't move in a normal helix the way normal particles do. Maybe they move in some weird new pattern. Do we have machine learning algorithms that can let us find those things? Can we discover things that we would have seen, decades ago just by eye, but now we need machines to help us scan through at very high rates. So that's the kind of thing I work on recently on Atlas.
Excellent. Yeah, because we have these collisions with the Large Hadron Collider. We're colliding every 25 nanoseconds, and we have more data, raw data, than YouTube has.
Yeah,
So for as a test bed, as somebody working in physics and also in machine learning, it's the best data set that we have on the planet, right? That we could
absolutely.
use to test these algorithms. And I think one thing that people aren't always aware of is that we've been doing this work for decades. I mean, it's not new. A lot of people are hearing about AI a lot more recently, but machine learning and developing these algorithms in order to search through that data set, it's not new for us.
That's right. And we look every 25 nanoseconds because that lets us look for really rare stuff that only comes once every trillion or once every quadrillion collisions. And that's wonderful, but it comes with some trade-offs. It means that we need really fast analysis of all of that data. We can't just like look at every single one and be like, was there something interesting in this one? How about this one? Like 50 years ago, we used to analyze these by computer, but the computer was like a person looking at these things by eye and finding traces. We can't do that anymore. Now our computers are digital and automated. So we have to be very careful about how we instruct them to look through this stuff because there might be something which by eye would be obvious to you, but a computer would be like, I wasn't told to look for that, so I'm just going to say no. So to me, it's really exciting that we have this data, and it might be that there's things in that data which, again, if you just showed them to us, if you put them on the screen right now, we'd be like, wow, that's something. But we could have just skimmed by them because our algorithms are blind to them. And so my team is trying to teach our algorithms to be more open-minded, to find things that might already exist in our data and be spectacular discoveries, but we just haven't taught our algorithms to look for them yet.
So it's a very exciting time for machine learning and for physics. And we don't know if there's something rare happening in our data set that we
Yeah.
haven't uncovered yet.
It's so difficult to explore it thoroughly. It's like landing a rover on Mars. You can't look under every single rock, where you need to plan for which rocks are most interesting, et cetera, et cetera. It really is a kind of exploration. And in that way, we don't know what we're going to find because it is exploration. Research is always, there's no promises for when you're going to make a discovery. People talk about it, you might see this, you might see this, but really the joy is the unknown. It's just looking in a place nobody's ever looked before.
And so maybe we can go back a little bit and what inspired you to do this kind of research? Because I always love to talk to colleagues and find out
Mhm.
what got them interested in particle physics or machine learning and why do you
Mhm.
want to work at CERN, for example?
Yeah, that's a great question. And I think it's important that people understand like how folks end up in different research areas. For me, I've always been interested in the questions of particle physics, but I was also interested in other things. I was interested in plasma physics. I was interested in materials. The thing that made me go into particle physics was discovering that the day-to-day work of particle physics is the kind of thing I enjoy. Like I actually tried plasma physics first, but I
Mm.
spent a summer like playing around with vacuum tubes and I was like, wow, I'm just really not into this. And the kid next to me loved it. And it's very personal and subjective what you're excited about doing every day. And then I spent another summer playing around with lasers in basements, trying to make new weird kinds of materials. And like I found it really frustrating because the laser never works. It's like 900 pieces, each of which is up 99% of the time, which means it's never up. And if you're excited about debugging the laser, that's fun, but I wasn't. So it wasn't fun for me. And again, another kid in the same lab had a great time. And then it wasn't until I spent a summer working in particle physics where I was like, oh, I'm writing programs to analyze data. I love doing that anyway. I was a computer science major. So I was like, oh, so the day-to-day work is fun puzzles and the big picture questions are super exciting, of course, because we're probing the fundamental nature of space and time and energy and matter and all that stuff. So I think that's why people end up where they do is that they find a place where the big questions are exciting, but also the day-to-day work is fun because we're not making big discoveries every day. It's mostly do you enjoy the day-to-day work? And for particle physics and machine learning in particular, I think these are really fun puzzles to work on every day.
Yeah, and a point that you just made about trying out plasma physics versus particle physics, I think it's a really good time to shout out at this point that if you're watching the video as it's gone out or a few weeks and maybe a month afterwards, then right now we have an opening for the CERN summer student program. So if you are an undergraduate in physics and some of the other STEM fields, then you should look out for this program and apply, and you get to spend 3 months at CERN seeing if this is the kind of career
Mhm.
that you want to go into. So it's very hands-on. There are lectures in the morning, and then in the afternoon, there's also the opportunity to work on a project with a researcher at CERN, either on machine learning, so it could be on something in the data science, or it can be more hands-on, something technical with one of the experiments or the accelerators, or in lots of different areas that we have at CERN. So right now, the application's just opened. And it's really worth checking that out and developing your application and putting that in and giving yourself a chance to come to CERN and learn more about what we're doing. So
It's a
I think
wonderful
it's
program. As an alum of that program, it was like one of the best summers of my life. I mean, not only did I get to play around with code and do some neutrino physics, I met kids from all over the world. I learned so many different pieces of different languages. I ate so many weird foods. I traveled all around Europe. Like, wow, what a great time. Really one of the best summers of my life.
great. So people watching this might have also heard you online as well, because you had a long-running podcast that finished last year, I believe,
Mhm.
and you've
Yeah.
started a new one. So maybe you could tell us about your podcasts and why you want to talk about physics and your curiosity online.
Yeah, so I've always been interested in making physics accessible because particle physics in particular has a little bit of an aura of inaccessibility. It's like weird quantum, this and that, and who could really understand it anyway? But the questions we're asking in particle physics are questions everybody wants to know the answer to. They're questions that connect with people who have any curiosity about the universe. What is everything made out of? Where did it all come from? How does it all work? These are questions we all want to know the answer to. And so I think the stuff that we're working on is stuff people want to hear about. And I think that it's possible to make the work that we do, even if it's very cutting edge and sophisticated, totally understandable. And so my project in my books and in the podcast is to bring people up to the forefront of knowledge without dumbing it down, just by explaining it clearly, the way that you do as well, for example. And I think that makes people feel included and it makes them feel like they understand why we do what we do and excited about the work that we do. And so I've been lucky enough to partner with other gifted communicators. I worked with Jorge Cham for a long time. We wrote a couple of books and we did a podcast. We had a television show on PBS, conveying all this stuff, and recently launched a podcast with Kelly Weinersmith. She's one of the authors of A City on Mars, which is a great book, and her husband Zach is the cartoonist behind SMBC Comics. And I just like working with people who have the same sort of like enthusiasm for sharing the joy of science and making the technical details accessible. There's a lot of popular science coverage out there, but a lot of it is a bit superficial. And I wanted to dive deeper, but still make it very accessible. And one way to do that is to include humor, to make it lighthearted. There's the kind of science communication where you feel like you're in the presence of great ideas or a great mind, but maybe you didn't really understand everything. Our approach approach is let's really dig deep, but then, give you breaks with silly jokes or, cartoons or whatever, to sort of, give your mind a little bit of sugar. Sometimes, it's helpful to have a break when you're downloading difficult ideas.
Yeah, I think there are these preconceptions about our research and about physics in general that it's very
Hmm.
complicated, and it does take a while to learn these things, but it's
Yeah.
not out of people's reach. And so I really appreciate the work that you've been doing and the fun, as you said, to it, because I think if you're having fun along the way, you kind of forget that you're working as well.
Yeah,
And it's one of
exactly.
the luxuries of our research is that we get to enjoy it, and then it doesn't feel like such hard work.
And I do have fun every day. Like I have fun coding. I have fun thinking about these questions. I have fun reading papers. It is fun for me. It's also just fun to talk to people about science. One of the reasons I enjoy a podcast is every week I get to spend a few hours talking about science with friends, and that's just fun. And I want people to get to experience that. So our podcast, Daniel and Kelly's Extraordinary Universe, is if you enjoy hanging out at a bar with friends talking about science, that's basically what it's like. So come join us for a conversation.
I think the other thing that people don't always appreciate about our collaboration is that there are thousands of us. We're a
Hmm.
big collaboration, and it's very social, and there's a lot of discussing. I mean, we spend a lot of our time in meetings. It's part of the job, but it's, some people have these preconceptions that physicists are sat by themselves and working on equations,
Mm.
but we're actually talking about things a lot.
Yeah, and it makes being a physicist very different kind of experience. You're not like in the basement building your own thing, and then 7 years later you come out with some result all by yourself, right? That's
Mhm.
one kind of physicist, but the kind we are, it's kind of you to say that there's a component of it that's being social. You could also say that it's political. I mean, a lot of getting stuff done in a big collaboration is figuring out how to get support for it and to get your project the resources, and that means personal resources, people spending their time on this because you can't do it all yourself. Another important aspect of it is that people become specialists. Like I didn't build the accelerator and build the detector and build the data acquisition system and analyze the data and write the papers and lead it all myself. I couldn't possibly. But that gives me an opportunity to focus on one area of that and become like a really deep expert in one niche area rather than having to learn all of these different skills. And not that one is better than another, but it's a very different way to be a physicist
Mhm.
than sort of jack of all trades person in the basement who's developing their whole experiment and analyzing the data and doing everything themselves. That's also wonderful. And again, no judgment. It's just like, what kind of physicist do you want to be? I'm not the kind who enjoys crawling around the detector with a screwdriver. Some people love it, more power to them. They get to do that. I get to nerd out with the machine learning algorithms, which I enjoy. So everybody wins.
Yeah, and it's the main part of teamwork is that we take people's
Exactly.
best skills and their passions and we bring them all together, and that's how we're able to discover new particles like the Higgs boson and how we're able to search for potential new particles as well.
Yeah, exactly.
Yeah.
And you get to meet people from all over the world, which is such a huge benefit, and learn how their cultures work and how they collaborate and the pain points and the smooth points of that kind of interaction. So I think you learn a lot about people also being in a big collaboration.
Now we've talked a lot about Atlas,
Hmm.
and I try to keep on top of what's being said about our collaboration. And recently, my notifications have been going off for different reasons. So there's a comet that is passing by that is also named 3I Atlas because the system that alerts us to these comets or asteroids that are passing by is the acronym is also Atlas. And so there's been a lot of talk about this comet because it's not from our solar system, and there's been some hypotheses that it's potentially not as natural as some would say. Personally, I don't subscribe to these hypotheses. I think that there's a lot of interesting science happening anyway. That's a really interesting thing to study in our universe, but it gets the conversation going, right,
Yeah.
about what would happen if aliens were to visit us on this planet and how, how would that go? And as someone who has grown up with sci-fi, I was inspired to do my research by Contact was one of the big
Mhm.
inspirations for me by Carl Sagan. the thought of what would happen if aliens came to visit is something that has crossed my mind a few times, and it has also crossed your mind because you have a book. It's out already now.
It is,
Yeah.
yes,
Do you
exactly.
have a
It's
copy with you with the
I
cover?
I do have a copy. It's called
Very nice.
"Do Aliens Speak Physics?" and I wrote it with my friend cartoonist Andy Warner.
Very nice. So it looks great, and I've been I must say I haven't finished it yet, but I have been enjoying reading it. And one of the th first things I wanted to ask you, well, maybe you could first tell us the premise of the book and what inspired you to write this book.
Sure, yeah. Just a quick comment on Three Eye Atlas. I agree that we should be open-minded and we should think broadly about what this might mean. And there could be a day that a visitor to our solar system is an alien ship. And I think that the planetary scientists and the folk and the astronomers have been very open-minded. I know there's an
Hmm.
effort to sort of cast them as closed-minded or dismissive. But if you look at what they've actually done, they've been very open-minded about what it could be. And the most important thing is to let the data speak, right? What do our observations tell us? And so far, very strongly, they tell us that this thing is a comet. It's weird and it's interesting because it's from another solar system, but it does look to be a comet. And personally, I'm disappointed in that. I wished it was an alien ship. I wanted it to be an alien ship. And I think that it's not widely enough appreciated how much physicists would be excited if aliens came. We're not dismissive of the concept because we don't want it to happen. We desperately do. It's just that, most of the time it's not aliens. And because it's most often not, and because we want it to happen, we have to be very skeptical, because it's very easy to fool yourself into believing something you want to believe. And that's sort of what my book is about as well, because I would love if aliens came. And one of the reasons I would love is not just to learn about where is life in the universe, but to learn the secrets those aliens might have already uncovered. I mean, if we have spent a few thousand years developing our understanding of the universe, or a few hundred years, depending on how you count, alien civilization could be much, much older. The
Hmm.
universe has been ready for life for billions of years. So, in principle, an alien civilization could have been doing some form of science for unfathomably long. What could they know about the universe? And could they come here and just tell us, right? Imagine leaping forward into our scientific future 1,000 years, 1,000,000 years. Like, it's mind blowing to think what that might actually be like. And it could really happen, right? If there really is life out there and they show up, that's a possibility. But it's very, very tempting. And it's also a little bit flattering to imagine that, like, the project we are on is a galactic project and it's shared by other species, and we're part of this, like, not just 5,000 people at CERN, but uncountably many aliens around the galaxy all working on the same project. It makes our physics sort of central in this way, and I feel like that's exciting, but it's also a little too flattering. And so it makes me skeptical, and it made me wonder what would actually happen if aliens arrived. Would we be able to talk to them about physics? Is our project of physics a sort of first steps for any intelligent species? Or are there many, many ways to be curious about the universe, to develop explanations and answers? And that led me down the path for lots of interesting philosophical questions about, what is the nature of the universe? How much of our explanation of it is, the map, and how much of it is the territory? How much of it do we know has been distorted by our human lens? Or can we possibly know whether we're revealing the truth of the universe or telling ourselves something about the way our minds work? So that's really what the book is about fundamentally.
Yeah, it's really interesting that you say that because going back to what we really started at the beginning of the conversation, we don't only have the ATLAS experiment on the
Mhm.
LHC, right? We also have CMS, which is the sibling experiment for ATLAS. These are two general purpose detectors where we compare our results, and we can't claim a discovery until we've compared our results with
Yeah.
each other, and we both have to find it. And then we also have ALICE and LHCb, who are also doing research on the Large Hadron Collider and other experiments and other research at CERN as well. And so then to touch on what you were just saying, being able to compare our results with an alien race would be a
Wow.
real test of are we are we biased? Just like you said, are we biased by
Mhm.
our human lens, or are we discovering this fundamental truth, which I think is really fascinating.
Yeah, and I think that most physicists don't think about this very much. And if they do, they think, oh, well, of course, what we're discovering is real. If you walk around CERN and you ask people, hey, is the Higgs boson real or is it just something in our models? They would say, of course it's real. We discovered it right here. They give a Nobel Prize for it. Like, what are you smoking? And we're going to get some. But that's a philosophical argument. It's not a scientific position. Like the scientific position is, can I predict the results of the experiments? Yes. And it turns out you need to include the Higgs boson in your model to accurately predict the results of collisions because we see that in our data. So you have to have the Higgs in your model or some equivalent of it. But does that mean that the Higgs is there when we're not looking? That the Higgs field is a real thing and not just a calculational tool? That's not something we can test scientifically, right? There's no test that can tell you if something is there when you're not looking, because by construction, you're not looking. And that's what we mean by, is it real? Is it out there in the universe? Was the Higgs Higgsing before there were humans, right? That's the philosophical question. And a lot of scientists take that extra leap and say, well, of course, we've seen data that supports it, therefore it's also real.
Hmm.
And, that's where I think we need some skepticism. So, well, if we don't have any data, then why do you feel that way? It's a philosophical argument, not a scientific one. There's no data that can answer the question. And so we should ask, well, are there arguments on the other side? Is it possible we're wrong about these philosophical kind of assumptions we're making? And that's what the book is about. Is like, let me make the strongest argument I can against that to say, like, maybe we're fooling ourselves. Maybe, the Higgs is just part of our calculational tool and it's not something that's really happening out there in the universe. What is the best argument you can make in that direction? Just to sort of explore and to try to open people's minds to these possibilities. Because I think that philosophy doesn't get enough attention, frankly, among physicists. I think a lot of them feel like philosophy is a waste of time, but they also have a strong opinion about philosophical viewpoints. They believe in scientific realism, most of them, without really, I think, thinking it through. And so one other thing I wanted to do with this book was bring to the popular science audience and also to the physics audience some interesting conversations that happen in the philosophy community, in the linguistics community, and in the anthropology community that are much more skeptical about this question, whether we could talk to aliens about physics, than I think most physicists are.
Yeah, I've met many colleagues that have very strong opinions on these areas without necessarily having, we don't talk about them in that way as philosophy. I must say, when I started reading your book, I was already a little bit conflicted, and you touched upon it when you were talking, because you said that, if we meet aliens, then, maybe they can jump us ahead in our understanding. And I really want that, and I
Yeah.
also really don't,
Oh
because
no.
no, but I love working it out. I love what we're
Yeah.
doing in our research to understand it ourselves.
Mm.
But there are things that I have had to accept that maybe I will never know, and it's going to be generations of scientists before we understand these things. So then I'd love a sneak peek of what the what the physics is, and like I really want us to discover dark
Mhm.
matter
Mhm.
sometime in the next sort of 30 or 40 years.
It's
But I'm I'm pragmatic that maybe there are some things that we'll just never know. So I was a little bit conflicted when I was reading that I was like, I do want to know, but I also want us to find it out. I think there's a joy in finding it out ourselves.
yeah. Yeah, as we were saying earlier, there's not just a joy in the questions, it's a joy in the process, right? It's
Hmm.
fun. It's fun to be on the hunt for a mystery and to put these clues together and try to figure it out. But it's hard if somebody came to you, Claire, and said, look, here are the answers to every physics question you've ever had. I'm just going to put them in this box on your desk. It's hard to believe you wouldn't ever open it, right?
Yeah. Yeah. Maybe I would yeah. It would be a temptation to just be like, oh,
Yes.
go on then. What's dark
I
matter?
know, right?
Yeah.
Because that's the amazing thing about these questions is it feels like there is an answer. Dark
Mm.
matter is something, right? There is a true history of the origin of the universe. There are reasons, there are explanations for the things we wonder about the universe, and they're out there. And so to imagine that somebody else has these answers, they like know them as fact and have data to support them, and they just haven't told us yet, that's frustrating. That's that's too tempting. But I think that in the book, what we talk about is ways that we might be able to talk to aliens about physics, but also ways that their alienness or our humanity might get in the way. But it's not a wet blanket kind of a book to say like psh, that's going to be impossible. It's really one of the best thing about aliens is that no matter what the answer is, it's amazing. Like either aliens show up and we can talk to them about physics because they do science the same way we do. They use math, they ask similar questions, et cetera, et cetera, et cetera. And we learn the secrets of the universe. Yay. Or they show up and they're not scientific in the same way we are, or they don't use math at all, or they're interested in totally different things. And then we learn something about ourselves. We learn something about the nature of this human lens. If we get to look through the universe through an alien lens for once, then we can triangulate. We go like, oh, this part is really about ourselves. And that's awesome too, because then we've learned something new and deep about our curiosity and our minds and the way we think and the way we ask questions and the kind of answers that we can accept. So, like with most questions with aliens, the most frustrating thing is not to know the answer because any of the answers are amazing.
Was there something when you were writing this book where you went down one path and the conclusions that you came up with like really surprised you? Was there something that you learned maybe about yourself or the way that we do research that as you were writing the book,
Mhm,
you thought
mhm.
about it in even more detail?
I learned a lot writing this book because it's not just like my primary area of expertise. Like as a particle physicist, I don't necessarily know about the deep history of science or all of that. And so for one of the chapters, we explored how science on Earth might have gone differently. Even if aliens are essentially equivalent to us scientifically and mathematically, and they ask similar questions, they might have just taken a very different road. I mean, imagine instead of aliens, just like 1,000 different Earths.
Hmm.
How much of the path we've taken through science is based on like random chance and flukes and somebody who lived or somebody who died or somebody who stumbled across something? And how much of it is inevitable? Like how much consistency would there be across 1,000 Earths? So we did that sort of experiment, and we did it in two ways. One is we looked back through the history of our discoveries and we tried to identify moments where it really was just happenstance that we made some discovery. And there's a lot of them, it turns out. One of my favorites is Becquerel's discovery of radioactivity. He put uranium on a photographic plate. And he had this plan for putting it out in the sunshine because he had this theory that uranium would absorb sunlight and then emit it onto the plate, which was totally wrong. And he didn't get to do his experiment because it was cloudy in Paris. And because he put that plate into a drawer instead of out in the sunshine, the next week when he saw that it actually had, uranium decays on it, he was able to conclude that it was the uranium itself that was emitting these things, and he discovered radioactivity, and that led directly to the whole quantum revolution. And so we could have made that discovery 100 years earlier. Like all the elements, we had like uranium in plates. We were using it for like coloring stuff. And photography was around decades and decades earlier. So we could have accelerated the quantum revolution by decades, if not a century, which could have like changed the whole context of like Einstein's work. And maybe instead of developing general relativity as a classical theory, he would have gone straight to quantum mechanics because he would have like grown up doing quantum mechanics. Who knows? And there's lots of examples like that. And then you can go way into the deep past. And here I had to do a lot of reading on like ancient Mayan astronomy and numerology and ancient Chinese astronomy because I was curious. On Earth, we had these populations, the Chinese, the Mayans, and the Mesopotamians, and they were all fairly independent. And, did they develop the same curiosity and the same sort of proto-science in the same way? Is it independently? Or is there like just one path there, or was it very different? And that was really fascinating to dig into. And, our Western tradition mostly comes from like the Babylonians and the Greeks and this kind of stuff. But the Chinese were taking a very different approach. Instead of being geometric, they were more algebraic, arithmetic. And the Mayans had very sophisticated astronomy, most of which unfortunately is lost because the Spanish burned it all when they arrived. But there's a fascinating experiment happening there where sort of three independent communities all began the same way. They looked at the night sky, they wondered about the patterns, they developed mathematics to describe it, though different mathematics. So, anyway, all that gives you a hint that there's a lot of different ways that science can go on a planet. So, when aliens arrive, they could be like wondering about very different things. They could have gone down a very different path. They could be like, why are you guys thinking about that? The answer to that is obvious. We're wondering about this. And we might be like, oh, yeah, we know how to do that. So it could be like a joyous, peanut butter plus chocolate sort of situation.
Yeah, I love the idea that it would be an exchange. I mean, it really depends on the technology that aliens would have if they came to visit. But it could be that they're still relatively early in their interstellar travel, and there's an exchange that we can have
Mhm.
of
Mhm.
things that we've learned and things that they've learned. And for me, also growing up with like science fiction, where a lot of this is also explored, these kind of topics. It's not just about the physics and the science. It's like you say, it's reflecting back on us and our humanity and our shared history of how we got to where we are. I love
Mhm.
that there's also that connection of not just looking at aliens, but
Mhm.
how Earth could have evolved differently, and people on Earth could have figured things out in different ways.
Yeah, and a lot of the science that we do comes from our personal curiosity. Like the reason that science gets done is because individual scientists end up sorting themselves into these areas because they're excited about it. You and I excited about this. Somebody else is like sloshing around the rainforest with wet socks counting spiders, and they're having the best time. And I would hate that. And like that's good, right? That we have a diversity of curiosity. But the questions that we ask in science depend on that sort of emotional and personal interest of individual scientists. And so, as a species, as a culture, the questions we're asking depend on our personal curiosity. And if that's emotional, it's not like logical, why I like this and not that. If that's emotional and cultural, then why should we expect aliens to have a significant or any overlap with us, right? They have a very different culture and emotional response to the universe, that the things they want to know the answers to, the things they think are fun to look into, the jobs they think are fun to have. And so I think it will be really fascinating to see how they do it, in the same way that it's fun to travel. Like I love going to a new city and discovering like, oh, look at the bizarre food they eat for breakfast. I never thought about having like spicy fish soup for breakfast. That's mind blowing. But it's a joyous moment because your mind is opened and you realize that you've been making assumptions you never even considered. There were other opportunities. And so, in one sense, having aliens arrive and have them be doing science the same way we do, and like we very quickly get to talk about the standard model and quantum gravity would be exciting, but it's also kind of like going to a new city and just discovering that it's all Starbucks. And you're like, okay, I get to have my drink, but it's, I didn't really learn anything, as opposed to like getting your mind blown by some new bit of culture. And that's the wonderful thing about traveling and being in these big international collaborations. So yeah, I think we could learn something about the universe and something about ourselves when the aliens come, either way. So I hope that, this new comet really is aliens.
Yeah, going back to what you said earlier, like we want it to be aliens. We want it to be the most,
Oh yeah.
exciting and to learn from this. But we also have to rein ourselves in and not let
Hmm.
our human biases and our human excitement about what it could be get in the way of the measurements and the research that we're doing. So, for example, on in our research, we intentionally hide some of the data from ourselves so
Hmm.
that we can prepare it. If we're looking for a new particle, we intentionally don't look at the interesting region so that our excitement of, oh, it could be a new particle
Yeah.
doesn't accidentally influence the data that we're analyzing and then make it look like there's a new particle there when there isn't actually one. And
Yeah.
so and I mean I grew up, I had the SETI screensaver on my computer as a child. Like it was one of the first things I downloaded off of the internet to install on the computer to be able to help the search for aliens. And it's been, we've been looking out for a very long time, processing signals coming
Hmm.
from space. It's not as though people are against the idea that there could be alien signals, but we do have to be, sadly, very pragmatic and very cautious because extraordinary claims do require extraordinary data to go along with them.
Exactly. I think there's a responsibility there that comes with potentially making big claims. And it goes back to what we were talking about earlier about sharing this with the wider public. We have a sophisticated understanding of statistics. We know how to interpret this and that and the other. But when we're explaining it to the general public, we need to make sure that it's appreciated in its context in a way that makes sense to them. And I think some of the reporting and the claims around this new comet have been very irresponsible. Like, it might be this, it might be that, and here's what we think. And other people, I think, are being less responsible about what it might be. And I think that's a shame because it hurts the credibility of science and science communicators more broadly. I'm also a big fan of the SETI project. I would love for us to hear from aliens. I think the SETI project should get more funding and more
Hmm.
attention. However, I'm also very pessimistic about the possibilities of that ever working out.
Mm.
Again, not Jill Tatar is doing a great job, and I love how broadly these folks are thinking about the kind of signals we could get. But I spent a lot of time talking to linguists and philosophers of language about how to decode an alien signal. And it seems like it might be hopeless because the message that we get is not like some pure form of ideas. It's their ideas translated into some code, right? And anytime you send a message, you're always encoding those ideas in some sort of symbols. Like right now, I'm translating my ideas into words and those words into puffs of air. And fortunately, because we've agreed on what these words mean, I hope that they create those ideas in your mind. But that's because we've agreed on the encoding and the decoding. But with aliens, who knows what encoding they use and what prospects do we have to infer that encoding and to invert it seem very, very limited because that encoding is never universal, right? There's no like way you can encode something which describes itself or which can only be interpreted in one way. There's always a cultural arbitrary choice you make when you're sending a message. And without knowing anything about the aliens' culture, without them being here, I think it might be impossible to invert that. Like, think about how badly we've done in decoding human languages. The some that we've cracked because we have like a cheat sheet, like the Rosetta Stone. But even that, it took 20 years after discovering the Rosetta Stone to crack the language. 20 years when we had all these examples because we made the wrong cultural assumptions the first time. And there are other languages that we've never cracked despite having cultural knowledge and lots of examples. So the idea that we would crack an alien language, like we don't even know if we crack it that we could recognize that we have cracked it, right?
Mm.
Like, how do you know when you've translated this into something that these ideas are what they meant if there's really truly alien? So that's why in the book I focus instead on the prospect of aliens arriving, because in that case, you have a context in common. It's your physical location. You can like point at stuff and attach this symbol to that object. And philosophers of language I spoke to said that that's the only possible way we could really make contact with aliens. So like again, love the SETI project and I want to support them and they're great people, but I don't know that that could really ever work out.
Yeah, I mean it's kind of the same way that we're doing particle physics that we have to look in lots of different regions to try and
Yeah,
understand, for example, dark matter and other potential new particles. And in the same way, if we want to be able to find signals from aliens, we've got to be looking in all places that we can be
absolutely.
looking.
And we should be looking and we should be listening because, there are prospects for crazy things like the aliens have been listening to us and they figured out our language and they speak
Mm.
back to us in an encoding we already recognize. I would love that. And it'd be tragic to not be listening. So we should definitely be listening. Also, because like linguists can be wrong. Maybe it'll be easy and who knows. But if I had to bet, then I would guess the best chance for really making a mental connection with aliens is when and if they arrive.
Yeah, and I think this is also something people don't necessarily understand about physicists and scientists is that we love to be wrong.
Yeah,
Like, I know
exactly.
that we get kind of attached to our ideas sometimes, but being wrong and then having new challenges to solve or something new to think about in a different way, that is exciting. And that is,
Yeah.
again, we've talked about it, the joy of the research that we're doing. So
Mhm.
some of us do get a bit attached to our ideas, but in general, being wrong is a great thing because it means there's more to learn.
Exactly. That's the biggest update when the universe tells you, you thought X, turns out Y. And that's why we're doing this, right? We're not here just to validate our assumptions or confirm some narrative. We're here to learn the truth of the universe. And that means updating our narrative and learning new things. And, the narrative is fluid, it's constantly being changed as we learn new things and get more data. And that's what we want. And so I think it's important people to understand, yeah, that the process of science is fluid.
Yeah, and so I'm also talking about learning. I'm aware that you have to go and teach a class quite soon, so I don't want to have you late for your class. I wanted to touch a little bit before we finish on science fiction, and
Mm.
I'm very cautious that I don't want to give spoilers to something that's coming out next year that may have some links to the book, if that makes sense. But if we speak generally, we also talked about Contact. I mean, in Contact, the way that the connection was made was through the physics and the maths, right? Are there science fiction books that also inspired you in terms of either writing the book or more generally? And are you excited about how we can explore the ideas that you talk about in the book in a fictional setting, for example?
Absolutely. Huge fan of science fiction. And I'm a big fan of Andy Weir's new book that I think you're referring to that's turning into a movie next year. And I read a lot of great science fiction that inspired me. Adrian Tchaikovsky is one of my favorites. The thing I love in science fiction are creative aliens. Aliens where you go, whoa, I never thought aliens could be like that. Of course, yeah. Because that's when somebody has identified some assumption everybody's been making and then questioned, like, well, why does it have to be that way? So I just finished Adrian Tchaikovsky's book, Shroud, which has
Hmm.
very creative aliens that I won't spoil. And he's got a great book, Children of Time, which is fantastic.
Mm.
I also really like Alastair Reynolds. He's actually a former astrophysicist, become science fiction author, which is inspiring. And in this book, Do Aliens Speak Physics? Every chapter has a very short science, sort of science fiction vignette. And the reason for that is the book talks about these concepts. Aliens might be like this, they might be like that. We might think this way. This philosophical argument says X or Y. But I also wanted to provide concrete examples. Like, what would it be like if aliens show up and they don't do math? Or if aliens show up and they're bored by our questions? Or if aliens show up and they're too smart and we can't understand what they're saying? What would that really be like? How would we discover that? And so we wrote just a couple pages for every chapter of a hypothetical contact scenario in that situation to give people like a concrete sense. And also because I love science fiction and the chance to write even short science fiction stories, it was too good to pass up. So I think that science fiction doesn't get enough credit. It's sometimes dismissed as like genre fiction, whatever. But these are folks being creative in the same way that like theoretical physicists are. They're imagining other ways the universe could be and pushing the boundaries of thought and being creative about the nature of space and time and matter and aliens. It's wonderful and it's inspiring, and I can't get enough of it.
Yeah, so I think you touched on also how I wanted to end is that for a lot of people, science fiction inspires them as their
Hmm.
first foray into science and into exploring these ideas. And I think your book is also a really nice bridge between the two. You have the science fiction elements, but also dive deeper into it. And I think for people who want to be inspired and to think about these concepts more, that's a really great way for them to get into that. So before we wrap up, is there anything else that you'd love to share with people or anywhere else that they can find you if they want to learn more about what you're doing?
Yeah, great conversation. Thanks very much. If you're interested in the book, you can find it at alienspeakphysics.com. If you want to hear me talk more about the universe and make jokes with my friend Kelly, you can check it out our podcast, Daniel and Kelly's Extraordinary Universe. I also have a TV show for preschoolers. So if you have little kids at home, we have a TV show called Eleanor Wonders Why on PBS. Teach your kids how to do science and answer questions. Thanks very much for the conversation.
Great. It was really great to chat with you, and I look forward to bumping into you at CERN or at a conference in the future. And yeah, great to chat.
Sounds good.